We have spent some time talking about production, how to transform inputs into output. We will be focusing on what is called the short-run production function. In the short run, we assume that only one factor of production can vary, while in the long run, all factors of production can vary. The short-run production function is usually defined for output, a function of labor, and for the multivariate function, Q equals a function of L and K, we want to hold the level of capital fixed and vary the level of labor. And this will be our working definition of the short-run production. The production function we have in quadrant number 1, in the beginning, you get increasingly better returns. In other words, each additional unit of input produces more and more output than the previous unit. There is, however, a point after which the marginal or additional contributions from additional units of input become smaller and smaller. This region is referred to as the region of eventually diminishing returns. We can actually continue the function a little further into a region where the returns are negative. In other words, we have gone beyond the maximum output level, and thereafter adding additional units of input will not contribute to increasing units of output. The purpose of this exercise is to show how we go from production on the factory floor to applying costs to the various units of input. What is the cost of producing each unit of output? We will then engage in transforming the production function into a cost function. We are transforming the production function, Q a function of L, into a cost function, C a function of Q. From what you observe, we have 4 quadrants here, and the quadrant at the bottom left is a 45-degree line reflecting the labor input. Reflecting truly is what it does because it's a 45-degree line, and we're going to use this as a mirror to flip the production function in the short run from a function that says quantity on the vertical axis is a function of labor on the horizontal axis to the bottom right hand quadrant. So imagine that the 45-degree line ran all the way across the screen. What we would have truly then would be a reflection of the production function, where the labor axis that was horizontal because of the 45-degree line will now become the vertical axis, and the quantity axis, which was vertical, will now become the horizontal axis. So we are reflecting the production function in the 45-degree line. And the reason we are doing this is because we want to now apply the prices of the factors of production, the price of labor and the price of capital, to come up with a cost function, C equals WL plus RK, and we are going to measure on the vertical axis in the upper right hand quadrant the cost of production when the quantity of capital is held fixed and labor is the only variable input. We are also going to hold the prices of the 2 factors constant, so that effectively we have cost a function of labor, and since labor is an inverse function of output, in other words output is a function of labor, we would have successfully reflected the production function in a 45-degree line and added the cost of capital to the equation. So we have a fixed cost because we are assuming that the input prices are constant, W and R are constant, and that the quantity of capital in the short run is constant. So we have RK being a constant, that will be our intercept, and we will have the production function, which is S-shaped, appearing in the upper right hand quadrant as inverse S. And now you understand why the cost function that reflects the production function will have effectively a reflected look, so that an S-shaped production function will be an inverse S-shaped cost function. So let us take the upper left-hand quadrant, the short-run production function, and we're going to reflect every point on that production function through a 45-degree mirror. When we multiply the vertical axis in the bottom right-hand quadrant by the cost of labor, we effectively have the variable cost. So we're going to take the L axis and scale it up by the magnitude of W. So if W is 1, effectively we have the same function. If W is 5, again the vertical axis will be 5 times. So we're multiplying the quantity of labor by the wage rate. That is how we're coming up with the vertical axis. Notice I have two inverse S-shaped curves. One passing through the origin, which is pretty much the production function from the bottom right-hand quadrant. And then there's a second function, which is identical to the total variable cost function, but it is shifted upward by the magnitude of the fixed cost, which is the RK product, where R is the price per unit capital times K, the quantity of capital. So that is our fixed cost. This exercise then shows how we take a production function and transform it into a cost function so that we go from Q, a function of L, to C, a function of Q. Recognize that effectively it is one production function transformed in pretty much a linearized way to give us cost, a function of output.